Hello everyone, last time we did quiz 2 and today we are going to discuss quiz 3. So let's start with the first question. So it is talking about which of the following molecule pi electron density in the ring is minimum. It is talking about the minimum pi electron density. So if you look at this question, so let me tell you what is pi electron density. So look at here. Suppose we have this benzene ring, and if we are going to attach a electron donating group, so electron donating group generally increases the electron density of the ring. So this increases the electron density. What is electron donating group? Generally, here we can say generally lone pair and negative charge, as well as alkyl group. They are donating one. Clear? Like here, if you look at this group, this is lone pair. Here nitrogen has a lone pair. So here this is donating one, electron donating. This is also electron donating. What is electron withdrawing here? Suppose I am going to attach like this. So it will pull the electron from the ring and ring becomes electron deficient. And these electron withdrawing groups are generally double and triple bond containing functional groups like this: carbon double bond carbon, carbon triple bond carbon, C triple bond N, NO2, aldehyde, ketone, ester. Clear? So you can see this is NO2, this is electron withdrawing. Here NO2 electron withdrawing. And here both NO2. So both are electron withdrawing. So more the electron withdrawing group, more deficient will be the benzene ring, and it is a less reactive as well at the same time. And this is also called as deactivator. Whenever we are going to attach electron withdrawing group, that deactivates the benzene ring, and once we are going to attach a donor group, then it activates the ring. That is called activator. So I think for question number 1 it should be D, because we have more withdrawing group and that pulls the electron from the ring and ring becomes electron deficient. Okay, so now move to the next question. Let me remove this. Okay. Now let's talk about question number 2. It is saying which comparison is not correct. Yes, not correct. So I told you that acidic strength, if you look at, if you are going to check the very first option, the acidic strength comparison, look at here. If you remove the proton from the given acid, it becomes like this. And this is CH3O minus. So if you look at the cardio, this is the resonance effect. Why? Because both donors are same, oxygen and oxygen. Clear? And this oxygen's negative is in resonance, so which means this conjugate base is a stable one. So more stable conjugate base, it means more acidic. So option A is absolutely correct. This is in correct order. Now the next B1, it is talking about basic strength. So what is basic strength? Suppose we have this methylamine and we have this nitrogen with the ring. So whenever we have this kind of example, you know, there is a point. Whenever we have a non-conjugated lone pair, that is always be available for the donation. What is basicity? Basicity is a tendency to donate electron to a proton. Clear? So if my lone pair is available for that donation, that means more basic. So this lone pair is a non-conjugated and this lone pair is a conjugated one. So we can say non-conjugated is more basic than conjugated. So this is a wrong order. It should be like this. Clear? Now see question. This is benzyl carbocation and this is methyl carbocation. This is ethyl, sorry, 2 carbon. So we know that it is a more stable. Why? Because positive charge is delocalized here. It is in resonance. And now the D1, this is CH3COH and this is benzoic acid. Benzoic is again more acidic. Why? Because my conjugate base is in resonance with the ring as well. And here you have just a one-time resonance carboxylate and a donor group here. The methyl is a donor one. Look at here. If I am going to remove a proton from the acid, it will be like this. And this is CH3COOH. Here you have a methyl donor, but this is not a donor. The benzene is a like electron withdrawing group. It will pull the electron from this carboxylate ion because this is sp2 hybridized carbon and sp2 hybridized carbons are the electronegative in nature. Makes sense? And this is proper alkyl group which is a donor one. So once you are going to attach a donor with the anion, that is always unstable, and once you are going to attach a withdrawing group with an anion, that is stabilize the negative charge. So more stable anion, more acidic will be the parent acid. So this is more acidic because the anion is more stable. So for question 2, it should be option number B. Clear? Now move to the next. Okay, it is talking about the configuration of the given compound. We all knew for the configuration we should first decide the priority, and if you have a group of atom, then priority is decided by the very first atom in each group. Suppose this is the chiral center, so we can expand this chiral center like this. Suppose downside we have a carbon. This is a carbon, okay? So we all knew this is 1 because first atom is oxygen, here first is carbon, so this is 2, this is 3 and this is 4th. So my lowest priority is attached on the horizontal axis, horizontal. This is called horizontal axis. This entire line is a horizontal one. Clear? So we have a rule HAR and HCS. What does it mean? It means whenever my lowest on the horizontal and the direction is supposed to be anti-clock, then it should be R, and when the lowest on horizontal direction is clock, then it should be S. So this is 1 to 2 and this is going anti-clock, so horizontal anti will be what? R. So this is R. Now let's check the bottom one. So this is 1, this is 2, this is 3, this is 4. Again my lowest on the horizontal, and this time 1 to 2. Again this is going anti-clock again. So what does it mean? Again R. So both will be R. So if you look at the options, the first option is RR, second is RS, third one is R and S, fourth one is S and S. So we will go with the A, R and R. Make sense? Okay, now the next question, question number 4. This is a reaction of alkene. Okay, this is a reaction of alkene. Okay, so whenever we have a alkyne and product is my trans alkene, this is trans or E. Look at the each reagent function. You know, H2 nickel will reduce triple bond into single bond, clear, in a syn addition, means both hydrogen must be in the same direction. H2PD BaSO4 also, you know, it will reduce the triple bond into a single bond. Now this is very important, lithium liquid ammonia. Oh, H2PD BaSO4, it converts triple bond into cis double bond, cis. But this one, liquid in lithium ammonia, lithium in liquid ammonia, it gives you trans alkene, trans alkene. I am going to tell you how to memorize this. Look at here. Ammonia starts with alphabet A. Am I right? This is NH3. So NH3 is what? Ammonia. So ammonia means alphabet A. A means NT. NT means trans. Trans means E. So this is trans. So it should be lithium in liquid ammonia. Clear? And now we are going to discuss question number 5. This is breaking of ether in the presence of hydrogen halide. So simple thing is that, look at here. Suppose you have ROR. Whenever any R, suppose R1, this is R2. Suppose any R1 or R2 is 1 degree. Then the reaction will be SN2. Okay. And we all knew what is SN2. Nucleophile attacks in the direction, nucleophile attacks on that direction which is less substituted, which is less substituted. So simple thing is that oxygen one side is methyl. If I am going to write here like this, suppose so oxygen right hand side methyl, left hand side benzyl ring. So methyl is a very small one, so it means the reaction is SN2. Clear? So SN2 means the negative part, which is Br minus, it is going to attack on this carbon. So bromine is bonded with the CH3 and hydrogen is bonded with the oxygen in this way, HBr. So carbon goes with bromine and oxygen with hydrogen. So you have phenol and methyl bromide. So phenol and methyl bromide. So option number D is absolutely correct. Now move to question 6. Let me remove this all. Okay. I think now it's visible. Yeah. Perfect. So now the next question is question number 6. It is talking about the reduction of carboxylic into primary alcohol. We all knew the reduction reaction, you know. Look at this. This is carboxylic. So carboxylic first reduced into aldehyde and then aldehyde is reduced into primary alcohol. Okay. And if you are going to reduce acid into primary alcohol directly, this is primary alcohol, then we should use here a strong reducing agent. And we all knew the most common strong reducing agent is LiAlH4, lithium aluminium hydride. So we have this one LiAlH4, so it will reduce this acid into primary alcohol. I hope it makes sense. Now the next question is very important. Question number 7. So it is the very first step is here Friedel-Crafts alkylation. We have a alkyl halide and AlCl3. So this chlorine goes out with this Cl, AlCl3 like this, and you have tertiary methyl as a electrophile, and it will direct at ortho and para. So let me check this. So you can go with the para, suppose this one, this is para, carbon, Me, Me and Me, like this. Clear? Now the next step is what? Next step is Cl2 FeCl3. This is chlorination reaction, and chlorination means Cl plus is electrophile and it is directed at ortho and para position. So for this lone pair, this is ortho, this is para, and this is ortho. My para is blocked here. So the only available position is ortho. So we should keep chlorine at ortho. So this one should be like this, OCS3, CMe3, and here we have chlorine. And now the next one is HBr with the heating again, the same one. You have to break HBr like this. CS3 goes with bromine, so CS3Br, and this O becomes OH. So in the last you have OH, and here you have CMe3, and here you have chlorine. Let me check the answer. Yes, OH, Cl, CMe3. So C is absolutely right. Okay, now the question number 8. We did, I think, 7. Yeah, we did 7. Question number 8. Okay, this is a very good question. So here we have initial reactant, which is my alkene, and now the product is my aldehyde. So look at the key function here. You know, BH3 THF H2O2, this is hydroboration oxidation. So what does it mean? Hydroboration oxidation means I can write here HBO. It is anti-Markovnikov rule of OH minus ion, means we have to attach OH according to anti-Markovnikov's. So if you draw the product here, it should be like this, CH2OH, and we all knew PCC is a mild oxidizing agent, so it will convert primary alcohol into aldehyde. So CH2 becomes CHO. I think first combination is absolutely right. This is wrong, B1, because once you are going to do the hydrolysis, we have a carbocation as intermediate, this. And we know that carbocation is intermediate, it means the OH attack on this position, so it should be like this. And once you are going to use PCC, PCC cannot oxidize the tertiary alcohol. This is tertiary alcohol. The oxidation of primary and secondary is only possible, not the tertiary one. Clear? Now it is BH3 THF H2O2 with OH and KMNO4. This is also the not correct, because again you have a tertiary alcohol. The tertiary cannot be oxidized. Here as well, this is Marconi OMDM. This is oxymercuration demercuration. And we all knew oxymercuration demercuration follows Markovnikov's rule. Markovnikov's means this is OMDM, the last option. OMDM means Markovnikov's addition of water. OH and attached by Markovnikov's rule. So Markovnikov's rule means it should be my alcohol, and again alcohol is tertiary, so it is not going to oxidize by PCC or any other oxidizing agent. Clear? So the right choice is only option A. Now the next one is, we have question 9. Okay. Now we have question 9. It is treated with COH with SOCl2. We all knew whenever you have a carboxylic acid and here SOCl2, H is removed by chlorine, so we have COCl and this is bromine here. So this is the B, structure of B. And the next one is amine treated with B. So this is simple as well. You know, Cl is a leaving group, so NH2 will be in place of chlorine, so it should be CONH2 like this. This is C. And third one is very simple as well. This is Halfman reaction. Halfman reaction means this CO is going to eliminate and we have only NH2 with metabromine. So which option is like this? Yeah, this one, NH2 and meta, we have bromine, so only D. Clear? Now the last question. Okay, this is a good question. Where does the above compound substitute electrophilic attack? So in which position the electrophile is going to attack? So first of all, you should know the nature of this group, and you can predict the nature once you have the idea about the structure. So CONHCH3, so if you expand this, it should be like this. C O double bond O and then NHCH3 like this. So you can see you have a double bond directly bonded with the ring. So double bond is a electron withdrawing one, so it will pull the electron, and we all knew electron withdrawing group will direct the incoming electrophile at meta position. So this is the meta one. So we will say meta is only the right choice. Clear? So this is all about the quiz 3, in which we have done the 10 questions. And these questions from stereochemistry, from alkene reactions, from oxidation, from reduction. So in the next quiz, we will do few more questions from different chapters. Please watch and please write down some important points and please share with your friends. Okay. Thank you so much for watching this.